Hello, everyone. Welcome to our glorious server mesh technology showcase segment.
Exciting.
It is. I'm Margaret Crone, your Director of Communications. And of course, with me as always is Stephen Sharif, our wonderful creative director.
I'm excited. We have a fun showcase today. I mean, this is something that I don't think a lot of companies go into. A lot of projects don't really talk about, and it can be a little bit on the techie side, but I think this is stuff that a lot of players like hearing about. And I know we got some exciting people to chat with today. What do you think,
Yeah.
Margaret?
And of course, we tried to make it as visually appealing as possible. Shout out to Mike Vecchio, as you
Oh,
you may
great
you
work.
may know him from all of our other graphics, but he's our graphics designer and he did a wonderful job on these slides. So hopefully they help portray what our wonderful engineering team is trying to showcase. So we will kind of introduce them. We have some new people who you've never met before. We'll kick it off first with Zach. If you want to talk about who you are, what you do at the studio, and maybe a little fun fact.
Hi guys, I'm Zach. I'm the technical director here at Intrepid Studios. I run the networking team and the engine team. I'm generally responsible for performance and making sure that the game scales to the amount of players that we want it to.
A hefty and lofty goal. Many of us players will have thoughts on that. And of course, we have Hunter with us, which some of you, if you hang out on our Discord, maybe have interacted with before.
Hi, yeah, thanks for having me. My name's Hunter. I am a game networking engineer at Intrepid Studios. I've been here for almost about 4 years now, and first initially started off as a gameplay engineer, and then I slowly worked my way over to networking because that's what I've come to find that I love, and I love solving the hard problems, and very excited to showcase to y'all what we've been working on.
The gameplay engineering just wasn't torture enough for Hunter, so he wanted to go straight
So he
straight
went to
into the
he went to the
fire.
impossible problems. Yeah.
Yes.
Oh my
I
gosh.
like solving problems like this, hard problems.
I think
Mhm.
It's a
solving
fun
problems is
problem to solve.
fun. Yeah. And then of course, last but not least, Anton.
Hello, I'm Anton. I'm a senior networking engineer over here at Intrepid. I moved straight into this position because, I wanted to suffer immediately. I didn't want to start with a gameplay.
All right. Well, let's kick it off, Zach. I think you have a little intro here for us as we move in.
Yeah.
So Zach, I'm sorry, just
Go
to
ahead.
start, a lot of people, sometimes don't know what networking is.
Yeah.
Talk to us about what is networking. What is a network layer?
At its core, networking is just the concept of moving a state from the server to the clients. That at its core, that is the problem we are trying to solve. We are trying to do that as fast as possible with as many players as possible. Since we are making a very, very large game, we have a lot of problems that most games don't usually have.
Yeah, and with regards to like an MMORPG versus like a peer-to-peer versus
Yeah.
like a small dedicated server,
Yep.
like our networking needs are intense because
Yes, they're
the
very
types of numbers we're looking at are extreme.
Yeah, everyone on the networking team here has worked on other multiplayer games before, and this is definitely the project where we have to get the most creative with how we are going to solve our scaling problems. Like we are working on an MMO. Most MMOs don't do what we're about to do here. They don't talk about how they made it so they can support thousands of players per server. So it's very much we have to kind of like figure out what has been done and do a lot of R&D to figure out what we need to do for our game.
Right. And kind of answering that question of what we need to do for our game starts out with, well, what is our game trying to achieve, right?
Yes. Yeah.
There are a lot of different types of MMOs, some that heavily, utilize instancing,
Yes.
some that, maybe don't care about replicating to hundreds
Yep.
of players at a given time. So first it starts with a vision. What is Ashes
Yep.
of Creation? And then that kind of leads you down the architectural path of,
Yes.
okay, what does that mean we have to set up?
Exactly.
Because this isn't out of the box Unreal Engine 5.
No,
this is a
not even
custom
close.
network layer. Yeah.
Yeah, this is fully custom, tailor-made for the needs that Ashes has. Like, this is not, none of this is off the shelf. None of this is standard Unreal. This is all built for the kind of game that we are making.
Right. And so how do you go about kind of, determining that architecture? What does that look like for a game like Ashes? And we've been working
Yeah.
on this for a number of years.
Yeah, for years.
Mm-hmm.
So I guess the first step is we need to figure out the requirements. Like, what do we actually need to, what are Ash's requirements? The first place we start is, we're an open world PvP game, so we can't really control where players go. We can't do typical matchmaking where we just, spin up more servers, put them on the new matchmaking servers, and not have these issues. We're an open world game. Anyone can go anywhere. We're a highly PvP game, so we need to have low latency. People can't just we can't do what other games do, where you just like lower your tick rates really low and then just simulate at a really, really low rate. Since we're action PvP, we can't do that. One of our, I guess, would you call this a game design pillar, Stephen? Like, this is like we don't want to do layering. Like, that's a very like
absolutely
game thing. We wanted so like you can go anywhere in the world, stand there, and the people who are there. Like,
yeah. And I was just going to say, like, game layering, obviously everyone on this call is a gamer who's played MMOs, and we played games that do layering.
Yep.
It's just a very different experience when you can switch channels,
Yep.
Yeah, it's like you're switching a different world.
A core like MMO memory for me is like, old WoW. You would go to the same place, like and there would be the same person there, dancing on top of a mailbox every single time.
Or dancing on top of a corpse and looking at you with hungry eyes.
And they were always there. And they were always there. And with layering, you don't get that. You don't get that same level of experience that we want to give to our players. And then I guess our last requirement, which is like, just a typical MMO requirement, is that we have, very, very high player count goals. And typically high player count goals with no layering don't really go together. So that's where it comes into like, we need to get really creative with how we're going to solve these problems.
And some of us, Hunter, Anton, we've played these games that have high player counts, but a lot of ways that they get around having higher player counts is by being less server adjudicated, less server authoritative, and more player, which has its own risks and isn't really preserving the integrity of that player experience.
Indeed, like some games do not do proper physics simulations on the server side to validate player movements in order to achieve that kind of thing, which means that, like, cheaters can have an easier time going through walls and stuff like that. Or I guess they do layering or sharding, where they have real high player counts, but technically not really, because they're kind of broken up.
I can't tell you how many times I've jumped into either some session-based game, or I don't want to call any of them out, but where there's just one single player that's either hacking or doing something, and they're just running around and ruining the experience for everyone. And it's because the way they've architected in such a way, it's easier for those types of experiences to occur.
Always trust the client, right?
Yeah, exactly.
You just made everyone sweat, Hunter.
Do we want to kind of transition that into talking about the issues that we are trying to address?
Yeah, of course. Yeah, so I guess the issues start with, it's like, we're making MMO in Unreal. The amount of entities we want on the server, it's just not really going to work with standard out-of-the-box Unreal replication and Unreal simulation. So there are two problems here. It's like, okay, even if we could fit all the players we want on a single server, we still can't replicate them, because those are two separate problems. We have the simulation and then the replication problem. So since this is a problem, and there is no standard Unreal solution for this, we had to go about making our own custom solution to solve these problems. And this is where IntrepidNet, I guess, was born. IntrepidNet is a fully distributed networking stack. It's tailor-made for additive creation, fully built in-house. None of this is off-the-shelf technology. It's all custom built for our game. We'll get into these more in a bit, but IntrepidNet is made up of quite a few different technologies. The one that people are most interested in, people are always talking about, is server meshing. We'll talk a lot about server meshing and how we implemented it for our game. We have inter-server replication, which is we have multiple servers and they're replicating to each other. How do we deal with that problem? We have our own microservice layer for servicing our communication, I guess, between our servers. We have dynamic gridding, which is very exciting, and you guys will like a lot.
Very
and then we
exciting.
have the replication graph, which is just more custom replication. I would almost call them formulas for our game. So we'll be going into all of this. This is very detailed, very tech heavy. So
Strap
need a
in,
theme.
buckle in.
Yeah, we need some like theme music for the IntrepidNet logo there too.
I know, they were so excited when Mike made a logo. They're like, it's
yeah,
a
I was like, oh, it's so
logo.
nice to have a logo.
I'm just
Love
thinking of like the Indiana Jones theme song right now.
da, 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 da. Yeah,
Right.
Totally.
So where do we start off with this?
Yeah, so I'm going to kick it over to Hunter, and he'll kind of like start with giving some of the base knowledge for like how Unreal works, and then he'll start with talking about how some of our server technology, our server meshing technology works.
Yeah, hello. So before we start diving too deep into IntrepidNet, there's probably a few terminologies that we wanted to preface with, just so that it helps the community and everyone else here follow along better with like the lingo and the terminology that we will be using. The first concept that we wanted to touch on is an actor. In Unreal Engine, you can think of an actor as like almost any physical representation of an object or an entity that's inside the world. As you can see on the photo, an actor can be anything, such as an NPC, a mount, a tent, a piece of cargo. Pretty much anything that you can visually see and represent is what we call an actor. And these actors, they can be replicated, which we'll get into on the next slide.
And PC would be a player character, for
Yes.
those who don't know. Right.
Personal caravan.
So touching on replication here, replication is a term you might often hear in networking. I believe Zach touched upon that a little bit briefly in his introduction. Replication is the process of synchronizing some sort of state. You can think of it like a value or a property that's on an actor on the server. And then it's synchronizing that state from the server to all the clients that are relevant to the said actor. This is important because of a concept called server authoritative networking. The server, when you think of like networking in video games, the server normally has authority over your game world. And the properties, they're normally updated and checked against the server, which can then be shared and synchronized between your clients, which is through the form of replication. This is also part of why you never want to trust the client, as we said earlier, because when networking, when the client does some action to the server, for instance, you always want to verify that action on the server in some way or shape, or that's how you can get hackers or cheaters or something disrupting your game, because they're able to just send anything they want to the server, and your server will just trust it without verifying. And then that's where you can get the concept of, like I said, hacking and or cheating. So as long as the server kind of holds your source of truth, the client sends the data that your server doesn't agree with, you can decline the actions and or kick or ban the user depending on how severe the action is they're taking that you're not trying to allow.
And obviously we've seen, a lot of games that we played in where as the latency becomes worse for certain players, or as the load on the server becomes higher to process, that replication can show some weird effects
Oh, yeah.
in games,
yeah.
right? Where,
Oh, yeah.
wait a minute, what's that person doing? That doesn't look right.
Yep, that's when you would. That's typically when you would get like rubber banding. Like if your servers
Mhm.
really slow down, because you would only get an update every X period of time.
Mhm.
Yeah, so as you can kind of see in the video we showed, you can kind of see like player one is going into the water. This is from the perspective of the server. So as player one enters the server, it'll be like, okay, player one is swimming. So now player two and three, since they're visually seeing player one swimming, they're going to get a state for player one saying they are swimming, and then that can kind of perform like the necessary actions of like seeing them play the swim animation or whatnot.
Yeah. And like I guess to add on to what Hunter is saying, this is pretty much the entire problem. Like you're doing this all the time for everything in the game
Right.
that's replicated all the time.
Every movement,
Yes.
every ability, everything you click
Yeah.
on, interact with, touch.
Yeah, all the
Yeah.
goblins that are running around, they're playing animations, the players moving stuff in their inventories, the
trees,
anything.
leaves
Yes.
moving subtly in
Well,
the wind.
yeah, the trees
So-
falling, being cut down. Yeah.
Yep.
So not everything needs to be replicated across
No.
the server, right? Some things can be client only, like
Yes.
the ways the leaves might move specifically. But when
Yeah.
the tree gets cut down, that needs to get replicated across.
Yeah. Well, and you can do interesting things to try and like reduce this problem. Like if we're talking about the wind, for example, you could just replicate the wind direction and speed.
Yes.
And then the client can just apply that to all the trees instead of you having, a specific replicated, wind and speed for each tree, for example.
Right. And that's part of the finesse of
Yeah.
replication,
Yeah,
right? Trying to identify.
reducing the problem. Yeah.
Exactly. That's right.
Yeah, a big part of our job, especially with working with gameplay, is trying to figure out how to make that as efficient and optimized as possible so that our game and servers can perform to the expectations we need.
And speaking of servers, server
Right.
meshing, what everyone's been excited to talk about.
Right, so now we do replication. So now, originally, we just talked about how replicating a one server works. So now, the first part of IntrepidNet is what we would like to call, what we basically normally know as server meshing. In Unreal Engine, your game normally works under a single process server scenario. That means all your clients are connected to a singular server that runs the entire game. Now, for an MMORPG like Ashes of Creation, this can't work for us, like for a few reasons Zach talked about in the previous slide. There's just, with the mass amount of entities and actors we have, simulating and processing the replication of all that for every actor in one server, that's pretty insane. Our solution, first and foremost, here is basically we had to modify Unreal Engine so that it is capable of having many server processes that are kind of meshed together or quilted together that allows us to use all these servers together to make up your whole entire game world or your game realm. This allows us to split up that simulation work between many of the server processes, and each server process has its own authoritative state of the world that it kind of owns and controls. This task, it was not a trivial task, and it required us ripping apart deep layers of Unreal Engine and their networking stack in order to really modify it to fit the architecture that we have really envisioned. Outside of this too, there's like a lot of proprietary programs as well that we've made that kind of run in the background to help it orchestrate all this functionality as well. And by using Unreal Engine's API and doing all this, we were also able to add a lot of minimal overhead for our engineers when developing for this solution. And it allows us general control over like how things replicate and where they replicate, that we'll get into in the next few slides. So right now you see we have like the static dynamic world grid. Okay, that's great. But now you're probably thinking, okay, now that we stitch many servers together, what is my experience like that in regards to traversing the world? Will I be able to see into the other servers from mine, or will I randomly just start seeing actors pop in and out of existence right in front of me? That kind of takes us to this slide. So our answer to that, of course, is we want to make this experience as seamless as possible for our players. If you cannot tell what's going on behind the scenes and everything that we are making, then that means we did our job right. If you can tell, then it probably means something's wrong, and we need to look at what we're doing here and how we can improve and optimize it further. Um, we've developed what we call here inter-server replication for this case, which means that instead of traditional replication, as we explained, was like server to clients, this is basically representing between servers now, or replication between servers. And we do this replication to what we call a proxy actor. As you can see in the video here, we can see there's like a transparent white wall going across the screen. That represents our in-game debug tools with our border regions being drawn. You can see that Vexillant is on one server, and then Kevin is on another one as he's on the other side of that border. So what Vexillant is seeing right now is actually not Kevin, but a proxy of Kevin, is what we have deemed it.
Is it really Kevin?
Yeah, who knows?
If
and
only we
Hunter,
could actually duplicate Kevin.
Hunter, expand a little bit on, a lot of people who obviously aren't familiar with game development, they might not understand the terminology of debugging tools, right? So to talk a little bit about what a debug tool is.
Right. So when making a networking solution as complicated as this, we need a lot of information about the state of the world, what's happening, where things are going on. So we've developed a lot of like debugging tools that can be used inside the game and outside of the game, which these tools kind of help us collect that information, see where all the important things are happening, see where a failure might be going on. So in this particular instance, we have a debug tool that's in game that allows our developers to kind of draw these server borders so that you can kind of see while you're playing, like, okay, there's a border here. And then if QA is testing something, they can be like, okay, we transferred across the server and then this broke. So that means something's probably wrong with the server transfer. So that can kind of just help you like narrow down more of the problem space and give you that necessary information of like what was going on at the time. Because without that, if we have it turned off, you pretty much hopefully should not be able to tell the difference between the proxy we talked about or the actual actor. You can kind of think of the proxies here as a puppet. Any actual action that was done by the actual actor on its own like authority server, which is the server that owns it, it's then replicated to this proxy on your server, which then gets replicated to yourself, so that you can kind of see the representation of Kevin as if he was on the same server as you. We do it in a form of like, we call it lightweight because it's an up-to-date copy of the original actor, but we can specifically, our developers can specifically control like what does and doesn't get sent to this actor so that we're more optimal in like what we're sending, how we're sending it, and when we're sending it. Whew, that was a mouthful.
So now, I think the other thing to think about, Hunter, Zach, Anton, is that not a lot of players obviously follow development of the games that they're excited about, right? They wait until the game is ready to play and marketing begins and they can join in and purchase or whatever. Obviously Ashes has followed a little bit of a different path where we're giving people a bit of insight into what it actually takes to make these types of games. And we generally tend not to delve too deeply into the highly technical components of our development process because that's where a little bit of a cliff starts to form of player interest, even viewership interest, because it's nice to have the magic work in the background and you don't necessarily care or want to know how or why it's working, just that it feels good, that it's responsive, and that it accomplishes from a gameplay loop perspective what you're expecting it to. But because of the level of complexity, because of the amount of effort, because of what we're trying to create is a next generation level of complexity of gaming, we feel it's important to provide you guys an opportunity to get some insight into what we're doing that's unique, into what we're doing that is going to service a long-term MMORPG at the scale that we need Ashes to be. And that requires some really smart people in the room who are creating proprietary technology that allows us to achieve that in a way that presents players with a game at the quality they expect. And so, I think this is a lot of fun to kind of, have you guys come and explain this front facing. It can be a mouthful, it can be a head full to kind of digest, but at the
we're not
same
even
time,
done.
I know we're nowhere near done, but at the same time, it gives you now an opportunity to really see how the sausage is made.
Right.
And I think that's cool.
Right.
Yeah.
I could talk about this all day.
People don't talk about this. There are so many games that are doing things like this. Not exactly, but like, there are other games that have to solve these problems, and
Yes.
other games don't talk about this. This is a first.
Absolutely.
Right. Yeah. So as you see in the video, you can see into the other server. But now you're probably thinking, okay, what if I want to interact with this proxy? How do I do that across the server boundary? Well, because the proxy is like a puppet controlled by the higher authority, we basically just now need events that we can send from the proxy up to its authority. And then we tell the authority that we want to modify data or execute some action on the authority server so that it can then replicate down to the proxy and then back to you. We have what we call a cross-server event or an inter-server event that's done through what's normally known as an RPC or remote procedure call, which allows pretty much just for this. Our goal with IntrepidNet is to make all the routing and the actions that we do as fast as possible so that we can keep the latency and interactions between servers a pretty seamless experience. And you hopefully shouldn't even be able to tell the difference between, like I said, a proxy or an authoritative actor.
Yeah, and I guess to add here, this is so important because these server borders that we're talking about, they're invisible. You won't know where they are. So I think the big important thing here is like we need to make it so PvP can happen on these borders without people noticing. And that's really the real crux of it here. That's why it has to be so fast.
Right. And as you can see in like the video here, we have some fighting across the border. You can see while we're fighting kind of over the boundary, combat and everything seems pretty seamless and smooth as you would expect it without any noticeable issues. This is kind of showcasing like what we can do with just those events and that replication we talked about. We can have these like in-depth battles or interactions between the servers with hardly any downside.
Yep.
So what we're trying to achieve here is the seamless experience that you hopefully can't tell where that border crossing is.
And the other important thing about this particular, this cross-server information and the border itself, which I think you guys are getting into a little bit later, is that these borders are not static. They can change. They are dynamic.
You're spoiling it, Steven.
Oh, I'm sorry. I'm sorry. I'm so sorry. This is my first time seeing the slide. Okay, go. No, go. I'm sorry.
I think you were talking about seamless transition, so we can move into that.
Yeah.
So if you look or go back one more, Maggie, I'm sorry. So if you kind of see in the video there as well, now that we can kind of do interactions to the proxies across the border, you may have noticed in the video, I did charge myself across the border, and then I basically attacked what we call the proxy of Kevin. However, during that charge, we did basically a server promotion that took place behind the scenes that you probably didn't notice. So if we go to the next slide, we can kind of see now we're introducing the concept of server transfers. This is kind of where IntrepidNet gets very complex. This allows us to not only share and split the statically defined server areas, but we can also transfer actors to new server areas that are moving across the world or happen to have a new server come up on top of it into a different server. And then this allows us to do basically that global load balancing across the realm. And then, so basically when a player or an actor is within range of this border, our system on the back end kind of begins a negotiation and the creation of a proxy so that it can replicate it to the nearby server. This doesn't only happen on like a 1x1 scenario that you might see here. Even if it's a 2x2 when you're in like the corner of 4 different servers, your proxy will then be replicated to on 3 different servers from the one authority. So that way, no matter where you are, whichever server you're in around that area, you'll still be able to see this actor on a different server. If that actor then fully crosses the border, going outside of the authority region of the server it's currently in, the 2 servers then kind of start negotiating what we call a promotion or a transfer. This is when now server A is passing over that authority we previously defined to server B. And then promotions, they're like a whole different beast. In order to do a lot of like the promotions, there's a couple things we have to do, such as like ensuring first you have to ensure the actor is like fully made with all of its components and children. We have to ensure they're all up to date with the entire state that was deemed necessary for the new copy to have, because we don't want to lose any data during this entire transfer.
And Hunter, people hear the term like, children and the state and whatnot. Elaborate a little bit about, what that means at a high level.
Right. So when we have all these entities, such as like an actor, actors can then have on them what we call components, which is basically building blocks that you can then add to your actor that kind of make up the actor, what it does, how it's supposed to act, things like that. So for example, you could have like an actor, and then that actor has an interactable component. So that means you can interact with this actor. Or it could have an inventory component. So that means, okay, this actor has something of like a bank, or it stores goods.
And to contextualize that, let's say, you have your mount out, you're not on your mount, right? But
Right.
Another player could walk up to your mount and they would be prompted with an interact that says to mount your mount. As you're moving across the boundary, that actor has that component that is the interactable component that needs to go with it.
Yes.
Right, because if you transfer this actor or you're proxying it, you still need to be able to do that interaction across the boundary. So we proxy that interaction component. And just like we can do cross-server events on the actor itself, we can also do them at the component level, so that way it can communicate with its authoritative one. Because we kind of treat the proxies as like a read-only concept. So the proxies are just visually kind of representing what the authority represents. So any data modifications or anything that has to happen at the authoritative level, so that way then the proxy can get updated appropriately across any server. That's kind of how we have like that central truth of the actor is whatever server it's authority on. Perfect. And there's only ever one copy of that.
I just want you to know this conversation so far has probably induced about 30 to 50 people now wanting to take computer science degrees.
That would be awesome.
Yeah, no, it's pretty cool stuff. It definitely took a lot of time and a lot of effort to try to figure out how we make these things possible. And after all this work, we're excited to be able to show it.
Although watching Kevin run back and forth is making me a little nauseous.
Yeah. So in the scenarios too, this also works where you may not be proxying to that nearby server, because say you teleport across the map. This kind of means that when promoting there, it kind of does the same exact route, except it may just need to make your actor instead of making a proxy of it. So it all falls kind of under the same generalized system.
Yep.
And then when we normally do have that proxy actor on the other server, that means when you're promoting, we can reuse your existing 2 actors that are from server A and server B, your authority and the proxy. And we can convert that proxy to the authority and then demote the authority one to a proxy. So this allows us to have that more seamless experience when you're swapping servers. So that way it's a lot faster. You don't need to send a lot more data to copy over to be created. And then there's not really any visual hitching at all when this happens, because we're not spawning or destroying a new one on the fly during that promotion.
And this helps also with client performance?
It can. Not going too into detail, but
yeah.
We'll talk
actors really aren't cheap. So replicating an actor can be expensive, and every new actor you kind of open and close to the client, which is basically like a create or a destroy, that just adds this additional overhead that we didn't want. So we can kind of negate it by just reusing the existing one we already have and then doing that swap. So that way you don't even notice anything happened. Because
You were
we
about
try
to ask
to.
something, Steven.
No, he got it on the spawn and destroy.
Nice.
Okay, yeah,
Yeah.
yeah. Like I said, our goal is to make it as seamless as possible. And one of the main pillars when we were making this entire system was we try not doing anything on the client. If all of our actions are kind of done on the server in a fast and efficient way, the client shouldn't notice anything happening at all. And that's kind of where this comes in, because we don't want the client to notice. So every time we're doing something, we're like, okay, how can we do this without affecting the client's experience? Because we don't want them to have a bad time.
Yeah.
Okay, so let's talk a little bit about how all this stuff is working. Because yeah, we are communicating between servers, we're sending events between servers, we are transferring between servers, but how is that information flowing? How do the clients end up seeing that stuff? And typically, the way this is done is you create a centralized replicator, and all the different servers from all across the realm send all the relevant information about all the different entities to that replicator. So let's say one server has a bunny, and that bunny moved around. It sends that information to the replicator. Another server has a goblin that took damage. It will send that information to the replicator. And then all the players will connect to that replicator, and the replicator will parse through all those different entities, decide which player should see which entities, and send that information to the specific player. However, this creates a few issues, and you might actually be able to see it from that graph there that we've just created a bottleneck. As this singular process now may need to keep track of hundreds of thousands of entities and send potentially hundreds of millions of updates to all those clients, because all those bunnies moving and the goblins and the players and the trees falling, all that information has to be passed through the replicator and then sent to each individual client.
And I guess something to add here too, Anton, is like this is that would just be moving the problem. We're trying to like like if we had a single server, this would be the same problem, where all the replication is happening on one place, and we're trying to not do that.
Yes, actually, we tested a solution like this during Alpha 1, and this bottleneck, it kind of affects how many players you can have in the realm as a total. Like, you can spawn all the servers you want, but at some point you hit a limit on the replicator itself, and it doesn't matter how many more servers you spawn. You are limited by that cap on the replicator. During Alpha 1, the number we got was like, I think, about 1,000 players, where after hitting that point, you can no longer really scale anymore.
And it's important to note that because of this more, I guess, for lack of a better term, archaic and monolithic approach, which many of us have likely experienced in older games, there are certain scenarios in those games that are multiplayer where you start to see that server is having trouble. And it's because it's hitting these types of choke points.
Yes, and in fact, when this replicator is overwhelmed, the entire realm will lag. It doesn't matter if you're alone in one server in a remote island, you will lag because there is a big battle on the other side of the realm.
I remember in so many games where I would be out hunting and peaceful, nobody's nearby, and I'm noticing everything is starting to churn. And I'm like, what is going on? And then I'll look into global chat and I'll see, oh shit, they're having a huge fight somewhere across the realm in a totally different part of the world, and I am suffering as a result of it.
Yeah.
Indeed. And
I guess that's a good bridge to what we're doing.
Yeah, it is a pretty good bridge, because basically we Ashes of Creation is trying to aim for player counts that we found out that centralized replicator does not support. So we had to come up with our own solution, and this is, from what we know, not a very common solution, possibly because it's more difficult to pull off. What we basically did is we completely got rid of that centralized replicator, and instead we had the servers themselves collaborate with the other servers around them and exchange information that way. That makes each individual server have all the data they need to serve the clients that are connected to them. In our scenario over here, you can see we have 4 servers and 2 clients are connected to each one of those servers. If we had a centralized replicator, all those 4 servers would be connected to that one replicator, and then all 8 clients would be connected to that one replicator too. So we've actually distributed the problem. We've eliminated the bottleneck, and we've also eliminated this one point of failure that existed beforehand, where if that one replicator fails, the entire realm goes down. And we can actually, have a look at the next slide, where we see how we are more fault tolerant than if we have a centralized replicator. And we can actually, you can swap to the next slide. There you go. We have the entire server grid over there. And if one server goes down, everyone else can keep playing it like normal. We patch that server up, we fix the issue, we bring it back up, and everyone else never experienced anything. The players that were connected to that one server got booted and then can rejoin just fine. If we had a centralized replicator, if that replicator went down, everyone gets booted. So, yeah. So that's another good benefit from our approach. Although the really big gain we achieved with this was the elimination of the bottleneck, and it actually lets us scale. We are truly distributed. We can just spawn new servers to a certain point, of course.
And this is not. And by the way, Anton, like, this is not just a strength, obviously, of the replication model of the server grid itself, being distributed in such a good way.
Mm-hmm.
But when you have to bring such a monolithic server down because of that, because of, let's say, whatever error you can't determine, that has a cascade effect across, everything. You're having to affect the database, to affect the login servers, to have the player queues going off again. The ability for this to truly be distributed and for us to be fault tolerant is an entirely different player experience when it comes to these large, massive MMORPG type settings.
Yeah, I mean, it's very typical, like with, an MMO, like that something else is happening in the world somewhere, someone's hacking, someone's, there's a really large raid or siege happening, and the server falls over, and then everyone gets kicked. With our model, that doesn't happen. The rest of the server is fine. Performance is still fine in the rest of the server. People can keep playing. If that server goes down, we'll deal with it. We'll spin it back up, and it will just seamlessly rejoin the grid once we're back in a good state.
And this, eliminating the replicator was definitely not easy. And it caused us quite a few problems, but let's investigate one of those problems and the solutions we came up to solve it. So because we did not want to create an really large connection network between all the different servers, we essentially connect the servers to the nearby servers, the neighboring, or like some that are close by. And that is fine in most situations. Over here, we can see there's 2 players in 2 neighboring servers. Those servers communicate. So if those 2 players are in a party, even though they might be a little bit too far away to see each other, they can still see each other on the map. However, in a more complex situation where that other player is maybe on the other side of their realm, now those servers do no longer have a direct connection to each other. So we have created a problem. How can player 1 see player 2 when player 2 is on the other side of the world? If we had a centralized replicator, sure, we have the data just there, we can figure it out, but we do not. What do we do about that? And to solve that issue, we created a concept called microservices. Microservices are, imagine them kind of like servers on top of the servers, like some database, for example, but it's active. It's not just storage, they're doing work. We have a node service that is responsible for leveling up and keeping track of all the nodes and the upgrades that have to be done to nodes. We have a population service that is doing the spawning across all the realms. And we have a social service, which would be, for example, what would affect the party example that we just talked about. This means that server 1 and server 8 on the diagram can connect to that social service and exchange the locations of those two players. That way, player 1 and player 8 can have exactly the information they need to be able to see each other on the map. And yep. What was it, Stephen?
Oh, nope, that wasn't me.
Oh, that wasn't you. Okay, sorry, my bad. Yeah, and this actually gave us some extra benefits. We were able to make some pretty cool tools with it because we wanted to be able to have like an overview of what happens to the entire realm. We wanted to be able to keep track of all the players, all the NPCs, see all the different gatherables being spawned, see all the trees. And that's kind of hard to do if we just connect to a single server and then see what's on that one server and then jump on another server and see what's there. So we created a service that keeps track of all entities in the world and a tool that can allow us to view those entities. And this is a pretty cool tool because we can see the players moving around, we can see them participating in events, we can see the NPCs dying, we can see them collect gatherables. So if there's any issue with the spawning of gatherables, we'll detect it and hopefully fix it. It's really cool.
I think the big thing to say here is like, we can see the entire world state, which we generally can't do because we're so distributed and everything's so server central. But since we have these services, we can make a debug service like this, and we can see the entire world.
Yeah,
yep,
we're always watching you.
Yeah, I also wanted to piggyback off of that, Anton, of your services. The services as well are also pretty much distributed, like going for our model, so that if one of those systems go down, it's not taking down the every game system. So if the chat service goes, or the social service, for example, goes down, you may just not be able to chat or form a party for a few minutes until it comes back up, but you should still be able to interact with like your guild, your node, your mail, etc. And we tried making the services as well fault tolerant, like we explained earlier. So that way they can come back up, go down, come back up on the fly, get hot fixed. And so that we can still provide that seamless experience while the feature may not be working, everything else should still be working in the meantime.
Right, and because they're componentized in this, microservices approach, right? There is not an interconnectivity where you have one failure in a single service causes a cascading effect across all the services, right?
Exactly.
They're independent of one another. That allows for a recovery time, a recovery process to stand back up while the other services continue their operations.
Exactly.
And then these debugging tools allow us to see where those problem areas are or what situation or actor might be causing a problem, right?
Exactly.
Yeah, we don't have all the tools, a slide for all the tools, but we do have monitoring tools for all the different services. We know when they're lagging, we know when they're down, we can monitor pretty much everything. It's pretty cool.
Yes, it's very cool. Cool. Now let's get into the really fun stuff now.
Yeah,
this one is something
really
that the community has actually been talking about quite a bit.
Yeah, I saw a bunch of videos. People have been talking a lot about this.
Yeah.
So go into it, Anton, because this is your thing.
Yeah. Oh God, I've been looking forward to, like, since I joined the company, I've been wanting to implement this, and this is an answer to a problem. And that problem that it's trying to answer is, sure, you have all those different servers, but usually player activity tends to condense to certain areas. Let's say a large PvP battle is happening at some place. And when that happens, that one server can be overwhelmed. And you usually wouldn't want to just create tiny servers for everything, because that can be incredibly expensive and wasteful. But having those smaller servers would be really useful. So what if you can do it dynamically? What if you can detect when a server is overwhelmed and then split it? This is what dynamic gridding is. And it can be a little bit tricky to implement. The difficulty of it is that you just now split a server and you want the players to not realize. There were casting abilities, they were running around, and a new server just spawned, they were moved there, and no one realized.
Yeah.
That is a difficulty there.
And something I want to add here is like
Yeah.
these cases in which we're splitting a server, they're complex, because if we're splitting a server, there's a lot going on. So
Yes.
it's not like we can, like, there's just a couple people, we can split them, we can do like a quick fade, and it will be fine. If we're splitting a server, it's because it's under load, and there's a lot of action going on. So we want to keep that action going on and not interrupt it while we balance the load across multiple servers.
And it's important to, call back again to the very beginning of this conversation, right? How do you determine the types of architecture necessary? You must first understand what is the mission statement of the game. And Ashes is built with a lot of open world, dynamic and emergent player behaviors that are attempting to encourage high player densities at any point within the open world locations, which makes this particular problem a requirement when determining architecture of how do we address this, right? And I'm not familiar with, and Zach, Anton, Hunter, I'm not sure if you guys are, but I'm not familiar with any other tech stack or networking approach that has a dynamic gridding solution in order to better accommodate and facilitate that emergent player density behavior.
Yeah, I mean, we are not the first people to try this. This is something that a lot of people have tried. It is the answer to scalability if you can get it right, and that is that is our mission here, is to get this right. We want to be the people that solve this problem, and because if we solve this, the level of battles and dynamicism, I guess, we'll be able to have in Ashes is going to be unparalleled to any other game.
Yeah, and to make something clear, we're not talking about the far future 5 years from now. This is currently in development, and we are hoping at least to have it available by Alpha 2.
And the server meshing part of it is already in game. Right?
Yeah, so
it's just the dynamic aspect of it.
Yeah, so the static part, is already going.
Yeah, it's been going for many months now.
Yeah, years now. And all of our dev test servers, people are on them every day, running it. It's fine. This is like where we're investing our dev time right now, is getting this perfect.
Getting this ready for the entrance of Alpha 2.
Yes.
Yep. And hopefully Ashes of Creation is going to be the first game that implements this technology and actually deploys it.
Yes.
That would be really fun.
You got to work quickly, guys, if you want that. Moving.
Very cool. This is exciting.
Right, do you want to talk about the
I think I'll pass it up
scalability?
to Hunter, yeah.
Yeah, I guess now that we've, all these slides before this, we were talking about distributing the problem, separating the problem into multiple servers, so we don't have to deal with thousands and thousands of players and on the same server doing replication. But we still have the core problem here, right? We can only split servers so far. We can't make them 10 meters by 10 meters. We can't do that. It's going to be too small. So we need to still support a high
you get a
number.
Server, you get a server.
Exactly. So we still need to solve the core problem of how many players can we get on a server, have them replicate and simulate at the same time. So I'll pass it over to Hunter, and he'll kind of go into I guess the problems that we have when we're with Unreal Replication, and how we've gone about speeding them up so we can support many hundreds of players on a server.
Yeah. So kind of piggybacking off what Zach said, like, what do we do when a large amount of players are, say, following your favorite streamer into a small area, and then like we can't just keep dividing our servers into such tiny areas, and that you're needing a single server that's still of a reasonable size to then be able to process the heavier load and replication that's happening in that exact area at that exact moment. So in order to do that, we have to then figure out how we can increase the number of players and entities that a single server can support. And this doing so will also help us increase our overall like concurrent user limits per realm. Because as a rough napkin math, of course, you take the players per server, multiply that by the number of servers, and there's your CCU, right? It's that easy.
Yeah, that's how it works.
Obviously. So I'm going to kind of go into now, we're going to touch back up on kind of what we explained earlier, like why is replication expensive? Like what's going on? So we kind of wanted to explain that, like on this slide here, for example, you can see an example of a CPU performance profile that we took during a large scale bot test. You can see here that like the single frame we're staring at took 150 milliseconds, for example. Now, 150 milliseconds may not seem like much, but when you want to, for example, you're talking about servers and tick rates. And if you're trying to target, say, a 30 or 60 frames per second or ticks per second server, you only get a budget of about like 33 milliseconds or 16 milliseconds per frame in order to keep that stable high tick time.
Can you talk a little bit about what you're referring to when you're talking about tick rates and ticks? People
Right.
might not be familiar with that.
So as your game server runs, it runs and processes basically the entire world at like an interval of ticks, or frames is what it's called. The faster you can do all that processing, the faster your gameplay and experience is going to be. If you're targeting, say, roughly 30 to 60 frames per second, which is a pretty good targets to have for like a game server of like an MMO that needs to be very fast paced and have like very good performance and
server
protection.
FPS is different than client FPS.
Yes,
Correct.
but they're
Because people might be like,
coupled.
30 is not acceptable.
No,
so I just want to make that
so
clear.
they're vaguely coupled.
Yeah.
So one of the things you would notice, like if server performance went down, is you would notice rubber banding, like when you see like people just jumping around the world, or you would notice your latency goes up, and you would notice that by like you're trying to do PvP and you feel and you cast Fireball and you feel the latency between the time you casted it and when it actually executed on the server.
Right.
So this time, these tick times that we're talking about, that's what it correlates to for the player.
Right, because normally when you do an action, the client triggers something, it tells the server, hey, do this, and the server then replicates back to your client. If these frames are taking a long time to process in between, that means your server just has artificial latency and it's taking a lot longer to then process that incoming message to then return back to you. So like in this 150 millisecond scenario, if our game was steadily running every frame at like 150 milliseconds of time to process, that would drop our server down to roughly like 6 ticks or 6 frames per second, which then you will really heavily around that time start feeling like latency, rubber banding, dropped packets, etc.
And that's not acceptable for an action combat PvP MMO. Like it just doesn't work.
Right. So
I played those games. It definitely doesn't work.
We all have blamed lag before, right?
Yeah.
Right?
So we know that this is unacceptable. What do we have to do to optimize this?
Right. So now this kind of tells us replication, and now it's like, okay, let's dive a bit deeper into why this replication is very expensive. One of the big, One of the big major factors replication can be slow is because first, when you want to do your replication, you have to gather and determine basically relevancy of every actor in the game to not only your connection, but every other connection that's being processed in that frame. So relevancy is used and needed to determine basically how far away an actor is from your player. And then there might be some other like comment some other checks that they may need to do, like is it visible or not. But for simplicity's sake, we're just going to base it off a distance for now. So then it's basically comparing that distance to you and saying, okay, are you eligible for me to replicate to you? Because we obviously don't want things being considered to replicate to you if it's like across the world. Like you don't care what's happening on the far northern end of the continent while you're all the way down on the southern end. Like that's just going to waste a lot of processing and bandwidth. So the relevancy checks, like this gets way more expensive the more players and more actors you have that are replicated, because then it's for every actor, for every player, am I within range of them?
Yeah, and when we're talking about an MMO, where you're gonna have thousands of players on the server, thousands of NPCs, tens of thousands of replicated actors, you just can't check you can't do a distance check on all of those things in a reasonable amount of time.
Right. And so this is an optimization here for networking purposes, but it also leads to then slowing down your CPU resources, because again, you have to do that like every tick or at every whatever interval you set to do these checks. If we looked at the previous example, for example, I believe I don't think it shows in the profile, but roughly a little bit over 1/3 of that total time in that profile was just doing the relevancy checks. A good thing about our model, though, because all of our servers are distributed, they only have to do those relevancy checks for just everything within that then distributed zone. As of if we had that central replicator, that replicator would then have to still process every single player, every single actor, etc. in the world in some way, shape, or form to then determine if it should be relevant to you or not. So by splitting up and doing the distributed server load like we're doing, this allows us then to kind of reduce that problem area, but it's still a problem.
It's still really big.
It's still a really big problem. Now, adding more servers to the solution, that can make it smaller and smaller, but eventually there's like, we want to get it as fast as possible. So it's like, how do we make this better? How do we make this faster?
To be clear, that profile was using it had a server meshing, and it still was 35% relevancy checks. So we need to reduce those relevancy checks. How do we do that? How can we tell Unreal not to do all those unnecessary checks? Well, Unreal in recent years introduced something called the replication graph, and that is something that gives the developers the ability to write a custom solution into how to handle all those relevancy checks and how to determine which players should see which actors when it comes to replication. And this, it can actually lead to some really great performance gains. We'll look at it in a bit. But let's start and see how we use this replication graph to solve specifically this relevancy check. On the map over there, we see you still cannot see too far away, but there are a couple actors that are really close to the player, that goblin over there and a loot box. And there is also a bear a little bit on a medium distance away and a bunny really far away. Now imagine that keeps stretching for 500 meters more and there's 200 more bunnies. Without the replication graph, we would have to check every single one of those bunnies and say, is this within my distance? Is this within my distance? And that's a problem. That's expensive to do. So what we're going to use the replication graph to do is we are going to create this grid where we eliminate all the cells that are far further away from us and only check the nearby cells. That allows us to only check these 3 actors that are around us, skipping potentially hundreds of other actors that are further away. And this can lead to a pretty big performance improvement. We noticed, and this is like highly varying depending on the scenario, of course, but on an average scenario, we noticed about a 1.5 times performance improvement, like a 35% reduction in our replication costs. This is pretty good. but it's still not fast enough. And if we analyze the problem a little bit, we'll see that we're talking and thinking about like the NPCs and the bear and the goblin, but we are also comparing our distance with all the trees, with all the bushes that you can pick up, with potentially some buildings that are destructible. Why are we doing that? Can we do something to improve this? And the answer is yes, we can. What we can do is we can monitor and see when these ores or these trees are changing. And when they're not changing, we can move them out of our grid. So we're not even considering them at all. We might have 2,000 trees in the area. Well, we're not even going to look at them because none of those trees just got cut down. If someone is cutting them down, then yes, we're going to move them temporarily into the special grid. And then once they're done cutting out and everyone sees that they were cut down, we put them back to the dormancy bucket. It's essentially, you can imagine like the actor is going to sleep for a little bit. And this gives us a really, really large improvement. We noticed in our tests about 5 times improvement in replication times. So far, if we also include the previous optimizations, we've improved our replication performance by 7 times. And yet that's still not fast enough. It's still not fast enough, mainly because of our worst case scenario. And that worst case scenario is people keep packing in that one small area. There's an event happening, there's some point they need to capture, 200 people run in the same area. Yes, you can ignore the relevancy to some faraway tree. That's great. That's again, that's more than welcome. But if 200 players can see each other, that means that 200 times 200, you're sending 40,000 updates per tick.
Yeah.
And
I guess one thing to add there, Anton, is this is typically when a game would introduce a new layer or a new shard. This is like typically that case. But as we talked about earlier, one of our goals is we don't want to do layering. We don't want to do sharding. We want everyone who's in the same area to be able to see each other.
Right, and you could then use like dynamic greeting to help in this scenario, but again, we can only make the servers so small and dynamic before we kind of run out of that room, so we still have to improve the scenario that's kind of happening around you.
Indeed. So we need to figure out a way to further improve this worst case scenario. And this is where we kind of hit an engine limit. And this engine limit is that the replication graph of Unreal is the replication tick in general, not just the replication graph, is single-threaded. And that's because the engine in general is single-threaded. Now, what does that mean? What does single-threaded mean? It means that all the processing happens in one core of the CPU. And we can move on to the next slide, by the way. But that means that even though the server might have 4 cores, all the other 3 cores are going to stand there and wait for the first thread to do all the processing. This is done normally in Unreal because it was not designed to be multi-threaded. It is a very single-threaded engine, and replication is probably the most single-threaded system out of all the systems in Unreal. So making it multi-threaded is incredibly difficult, and at least I am not aware of it being done before. I tried to do some research around it at the time, and everyone was saying basically that it's impossible. But we did it anyway. We persevered through, and we multi-threaded the Unreal replication tick. And well, looking at the results, they did not disappoint. We actually gained, and there's a graph showing it on the next slide, but we gained a 2.5 times improvement, 2.4 times to be more exact, in our replication ticks.
Huge.
Yeah, it was a really, really big improvement in our replication, and it's probably necessary to achieve the player counts that we're targeting for. I don't think it would be possible without doing this. And the really important thing to note about this optimization and why it's like such a big deal compared to like the 5 times improvement we saw before from dormancy is that this improvement helps equally even on the worst case scenario. The other ones in the worst case scenario, they're helpful, but they're not that helpful. This is incredibly important even on the worst case scenario. And if we add it on all the other improvements we've done so far, we've actually achieved a total improvement of the total reduction in our replication tick by 94%. So we are only at 6% of the original cost for replication. This was actually a huge win for our team. But there's still many more things that need to be done. Ashes of Creation is an incredibly ambitious MMO in terms of scale, and we need to do a lot of work in order to hit our goals.
And this is obviously, again, going back to the start of this whole conversation. What is Ashes of Creation trying to be, and what does it then require of the tech stack we are using in order to become that? And when we said in 2017 that we are looking to bring massive back to massively multiplayer, having an engine with the graphical fidelity, the front end that Unreal provides is so important to the immersive nature, to the beauty of the world, to the quality of the setting, but then coupled with a proprietary back end that can facilitate the same player experience that a massively multiplayer world wants to provide. That's the dream. That is what Ashes is trying to be.
Exactly.
Phenomenal work here, guys.
Yeah, great job.
This is huge.
Yeah. I'd like to take a moment, I guess, to shout out the team. The team has done an incredible job. We are pushing MMO tech to where it's never gone, and we intend to keep doing this moving forward. Hunter, Alex, Kevin, Andrew, Anton, Adam, Ish, Doug, they've all done amazing work, to get us to this point where we're at today, and I'm sure they'll keep doing it moving forward. If you're interested in working on problems like this, send us an application. We're always looking for people who want to work on this, who have experience working on tech like this. Please send us an application. We're always interested.
And we know that like this showcase, this tech talk, this TED talk, this GDC talk, whatever we want to apply to this in-depth technical discussion, is going to appeal not just to people who are aspiring, obviously, within this field, to learn it, to do it, to this is their career going forward, but also to those of you who have been within this field of work and who yearn to work on the types of problems that we're discussing here in this showcase. We have a phenomenal culture at Intrepid. We have a phenomenal project in our hands that is, no shortage of problems that need to be solved. And one thing that our community has done a phenomenal job with is helping to evangelize the project and the company. And we're here to say that we have apps open. We have positions that are available. And if you want to be a part of this team, or if you want to help others find this team so that they can apply, please share this link, share this video with others, go on, social media and let people know we're working on some pretty next generation tech that is going to change the face of massively multiplayer when it comes to a genre. So, very excited and proud of what your team has accomplished. You guys, I know, are working every single day and doing a phenomenal job. Congratulations. Just very well done.
Thank you.
Thank you.
And it's great to experience it in game too. And I know that, our PI folks have already experienced that in our Node Wars test as well. So maybe they didn't even realize it.
I might have not.
Yeah, they
Yep.
might not have noticed, but there were definitely server workers working hard in that, and we were capturing data, so we super duper appreciate it. And as we head into Alpha 2, we're only going to get more data and be able to continue to push on. And as the folks here have stated, moving towards more of that dynamic state.
Yeah, it's been in progress. It's going to be in progress still for many years as we continually find new ways to advance it and make it better. We're committed to providing kind of like that quality we want for our players. And as a lot of us have played MMOs in the past, we just like networking was the big stopper for a lot of things. And we're trying to do something different and trying to make that a better experience for not only our game, but many more games to come. If other companies were able to like wanting to adapt to a new tech style or try to figure out their networking issues.
Yeah, and of course, all of us here are huge MMO fans, and I know those of you who are watching are as well, obviously, if you're sitting through this. But of course, the plan for us is to continue to create an amazing game and push forward and continue to change things even after post-launch. We'll continue to try to drive things forward. So thank you for joining us, and thank you to Hunter and Zach and Anton for your time and putting together an amazing deck. A little extra shout out to Mike for putting together all the graphics.
Mike did such a good job.
And
Oh,
Kyle
big
for
shout out to
helping.
Mike.
Great job.
Yes.
Kyle for helping capture some of the little footage pieces to make sure that they looked great. We super appreciate it. Any final words, Stephen, to wrap things
Yeah,
up?
absolutely. Just, out in the community, let us know. These are always the more risky takes that we provide insights to in our monthly updates because they are so tech heavy. And, we know that this has an appeal to perhaps a smaller audience, but give us your feedback. Give us your thoughts. What did you think of this presentation? How do you enjoy, learning a little bit more in-depth under the hood conversation about what it takes to make these types of games, to make Ashes of Creation, that dream of all of ours? How does it appeal to you? What are your questions? What are your thoughts? Leave us comments in the YouTube channel, on Twitter and different social medias and Discord and on our forums. Obviously, the community team continues to do a bang up job of collecting your insights and bringing it back to the team. But we enjoy sharing this and giving our perhaps more sheltered developers who are in the behind the scenes making all the magic and everything work an opportunity to come out and talk about how they are literally the magic that makes the wheels turn for this bus. And it's a great opportunity, I think, for them to come out, see a little daylight and bask in the sun of what is the glory that our community looks to them and says, thank you for providing an opportunity to enjoy a game at this scale, because it would not be possible, obviously, without your guys' hard work. And so with that, I think we'll see you guys back on stream.
We'll see you on the flip side.